Right, question 49. So you've got here, value V of a long-term investment may be modelled as a continuous variable. It says the rate of increase of V, so that's dV dt, is directly proportional to the value of V, so positive V, because it's directly, it's increased rather, rate of increase. So then, to get the differential equation, dV dt will equal kV, right? Bringing that constant k. To show that this is true, well, if we separate the variables, so dv by v, take the v over and divide, because you're timesing it, take it over and divide. K then dt, take the dt up and times. This will be log v, this will be kt plus c, constant. So then you could, what you do then, of course you take the log over, okay? And when you take the log ln over, you do the opposite, the inverse, which is en. Okay, so you get this. And then by rules of indices, right, because you're adding powers here, this is the same as timesing the terms. Okay, because when you add powers, you're timesing the terms, aren't you? Okay, and then it says show that this is true, a to the kt. Well, we've sort of got that because it says where a, k are constants. Well, actually, e to the c is a constant, isn't it? Because c is a constant, e to the c is a constant. So we just say, look, set e to the c equals to a, okay, a constant. We're allowed to do that because e to the c is a constant, so a is a constant. Right, it doesn't change anything. Okay, we're done. So we've got that. Then we go on to part C. Now it's important to remember, right? But if you couldn't get this out, you can still do part C. Okay, you can still pick up marks. Okay, so don't worry if you struggled there with part A, right? If you didn't do it, you can still go on to part C then. And it says value of the investment at 2 years is 292, and its value at 28 years is 637. Okay, so when t is 2, v is 292, and when t is 28, v is 637. So 292 equals a e to the 2k. 637 equals a e to the 28k. Okay. What we'll do then is call these 1 and 2 and divide, right? If you divide, you've got a e to the 28k divided by a e to the 2k equals 637 over 292. The a's will cancel, and then with e's, of course, with the powers, you take them away, so that'll be 26k equals this. So if you take the e over the other side, take the e over, you do the inverse, which is ln, and then to get k, then you do ln 637 292 divide by 26. We're done. Let's do that again. We get the one, 0.03. That's what we're asking for there. Okay, so k we know is 0.03, and then it says find the value of a correct to the nearest integer. So what we're going to do then to get a is put it then into put it back into 1 or 2, right? So sub it back in. So if you put it into 1, okay, so we got 292 equals a up here, yes. So 292 equals a e to the 2 times 0.03, okay, and then a, of course, then will be 292 divided by e to the power, and that's going to be 0.06, isn't it? We get 274.995, and it says the nearest integer, so that'll be 270. What am I saying? 275. Oh gosh, that's better, isn't it? I can write properly now. So it says find the initial value of the investment, giving your answer correct to the nearest pound. So initial value, okay. Well, if we know now v equals a to the kt, remember that. And of course, we know now a is 275, k is 0.03. Okay, so you can say, look, when t equals 0, that's the initial value, isn't it? V will equal 275 e to the 0. Okay. Oh, that's easy, isn't it? Because 0.03 times 0 is 0. So then e to the 0 is 1. So the initial value will also be £275.